Okay, so again, like, and we'll talk about base E logs. For some reason, base E logs really bother people, but they shouldn't. And that's easy for me to say, they shouldn't, but they do. So let's talk about those real quickly. Okay, so a base, ignore all this right here if you're at home. I'm just, tell you what. So if you ever see a log like this, they're just telling you there's a base 2 logarithm involved. And a base 2 logarithm meant, that, and like if I'm wondering what that is, again, this comes from an expression like that. Okay, it's basically saying 2 raised to what power would end up giving me 3? Now, I don't know what the answer to that is. I have no idea. I'll never know exactly because it's an irrational power right there. But I know that it's not 1, because 2 to the first would give me 2, right? And I know that it's not 2, because 2 squared would give me 4. So it's somewhere in between that 1 and 2. That I do know. Are you with me? Yes, no? So I don't know, 1.5, something like that. But because I rewrite it as a logarithm, this expression means that decimal. But in the old days, we didn't have a way to do this. All of our calculators, they had 2 buttons on them. Log and natural log, ln. Okay, and if you're like, why didn't they call it NL? Because it came from the French, and the French called it the logarithm, or natural, or something. So they called it the LN. But the ln log is this log, log base E. High school students across the country would have rejoiced if they had just said, why didn't you just call it log base E? And I hear you, it would have been a lot easier. But you will see after you get out of 10th grade, you won't be troubled by that anymore. You'll start getting it down in your head. It doesn't mean log the E. It means the base, instead of being a 2, that is the same thing as this. So like if I'm logging a value of x, it's the same thing as logging the x with the base of e. It means the same thing. I just don't write it with a log base e. Does that make sense? Yeah. Now it bothers people, but I don't know. I guess I don't know why. I guess I understand a little bit that people don't confuse ln of x with log e of x. That's not true. Okay? ln of x, the ln part means log base e. So whatever you're ln'ing, you are log base e. Okay? Now, that's the natural log. Same thing with regular log. If I see a regular log of x, that means it's understood that that's a 10. All right? So when we used to do problems, they were a lot different than what you do. Like for instance, you tell me what would you do to solve this log equation? What would you have done? Oh, let me change this to what would you have done to solve for x? You'd have exponentiated with a 3, right? So you would have come in here and exponentiated with a 3. That would have all canceled, right? And you would have had x equals 3 to the 4th, which is 81. You'd have been done. Well, we didn't work with log base 3 when I was a kid. So we couldn't do stuff like this. We weren't, actually, you know what? This is really a better example. What if I give you this? What would you have done to solve this? This is a better example. You would have used a
log base 2.
A log base 2 to get rid of this, wouldn't you? Yeah. Right? Because you know that a log base 2 is not going to help anything on the left, but a log base 2 of that simplifies, doesn't it? And you could cancel the log 2 and the 2 out, and you'd be left with x log base 2 of 3. But this wasn't useful to us because we didn't have log base 2 on my calculator. So if somebody said, hey, type that in your calculator, you were like, So here's what we did. We log base 10 both sides. And you may go, well, how does that help you? And remember, you don't write, I'm going to put the 10 there, but remember, we would not have written that because it's understood. Now, does that cancel? It does not. So how do we solve for x?
3 equals 10, yeah. Wait, 3.
What rule did we learn on Friday that allowed me to do something with that x? Do you remember it? I can swing it to the front. And if I swing it to the front, now again, I wouldn't have written those 10s there, but I'm just doing them to kind of help you with familiarity. Now how could I solve for x? I could just divide by the same log on both sides, right? And then that cancels, and I get x equals log 3 base 10 over log 2. And that's what we used to do, except we never wrote the 10s. I was just doing that to kind of help you with your visual of it. Are y'all with me? Well, if you think back to what we did initially, and then what I have here at the end, log base 2ing both sides. Check this out again. Cancels that. This gets you to a rule we're going to do today. And that is log base 2 of 3 is the same thing as logging the 3 on the top and logging the 2 on the bottom. And that's called the change of base rule. That makes sense? And this would allow me back in the 80s and 90s to use my log button. Or in the early 80s when nobody even had a calculator, or very few people did, to pull out our book and use the log tables in the back. Because the log tables in the back are going to be base 10 or natural log tables. College books, when I was in college, even in the early 90s, they did it with the natural log. Check this out. They said, I'm going to natural log both sides. Now when I natural log, does anything cancel here? No, nothing cancels. By the way, I don't make that for instance. If I just natural log both sides, nothing cancels. But what can I still do? Swing the x out front and divide the ln2. But that's the change of base rule again. This can change the base, log the 3 over log the 2. I don't have to use base 10. I could log 3 over log 2 in base E, which is the natural log. I could log the 3 and log the 2 in base 7. I can use any base I want. That's what the change of base rule says, and it's written in your notes somewhere. We'll pop into it. It's on your formula sheet, probably at the very bottom. But at the very bottom it says change of base rule. It says if I have a log like this, I can log the number you're logging and divide it by log of the base for any base I want. But if you get to pick the base, why not pick something that's on your calculator? So most people change it to ln3 over ln2 or log 3 over log 2 because those are understood bases. But we don't need to do that anymore because when I hit the log button in my calculator, this pops up and it allows me to enter a 2 and enter a 3. So since the dawn of calculators, that just makes life a whole lot easier.
So we don't have to know that.
But you will definitely have to know this change of base rule, but not to solve. I'll show you today and maybe tomorrow how we're going to run into math team questions where this change of base rule starts showing up. Because you right here, you're like, oh, so you can divide logarithms. Like right now, do we have a rule for dividing logarithms? Some of y'all think, yeah, you said to subtract logs, I divide. Well, I didn't really say to divide the logarithms. I said to subtract logs, you do what? And I said it a bunch of times. I said, keep the log and divide what you're logging. But this is not a rule for dividing 2 logarithms, is it? It's a rule for subtracting 2 logarithms. There is no rule for dividing 2 logarithms except the change of base rule. There's no rule for multiplying two logarithms, except maybe getting lucky with the change of base rule. So for me to say, how would you divide these two logarithms? Well, I have to have the same base, but if I did, I could basically turn the 2 into the base and the 3 into the number I'm logging. I could rewrite it as one log. But that only works if I have the same base. And these are the kind of things that really start bothering people, because it's like the brain starts, it's like that Far Side comic where the guy's like, man, excuse my brain's full. I mean, that usually is about the time people's brain starts filling up with all this stuff. And practice makes better. It does. I mean, it's not easy, but it does make it better. So anyway, I mentioned that, but what was the original question? What were we talking about?
I was just talking.
Because I wanted to talk about, I was going to talk about that today anyway, but
the problem is it's like log base 10, 20 over 9. Like I just don't understand.
this log base. Oh, and they're saying expand it.
Yeah,
Okay, so expand it just means use the rules that you know about division, logs of fractions, to expand it into two logs being subtracted. So
no, it was so it was like if log 10 equals, or if log 10 9 equals 0.95 and log 10 to the 2 equals 0.3, find the following. And then it was log 10 20 over 9. And so I thought it would be like
it says 0.3 or 0.301?
0.30.
30?
Yeah,
Oh, you made it nice. And what they say about log 10 of 9?
0.95.
Okay, so let me just talk through, because we didn't do one of these.
No, yeah.
Okay, so what they're saying is, and this is what they want you to do. They want you to take a nice, clean, simplified logarithm and break it up so that you can use these values. So let's think about it. This would end up being what? A log of a fraction
Log 10 to the 20
would be a log 10 of 20.
minus log 10 of 9.
Okay, so good start. And again, I don't need those 10s there. Did the book have the 10s there?
Yeah.
If they did, they're doing it only because it's maybe early in the game and they're trying to be kind. In the future, they wouldn't have a 10 there, a 10 there, a 10 there, a 10 there, or a 10 there. It would be understood. But does this make sense why I can do this? I'm using this rule. Now if you're thinking, why would you do that? You have it all nice and simplified. Well, they're giving you approximate values. They're trying to see if you can do this without a calculator. And a lot of times on a math team tournament test, they'll say, if that's A and that's B, write this in terms of A and B. So here's what they're trying to do now. Now right now, look, log base 10 of 9. I have that value. Are you with me? Yes, no? So I should be able to take that and replace it with 0.95. Okay, so what can I maybe do with this? Can I break that up 20?
I mean, would it be 3?
3 logs?
No, would it be like the number 3 because log 2 is 0.3? And
Yeah, but I have log of 20. Can you break a log of 20 up? How?
2 and 10.
So if that's 2 times 10, your rule for multiplying things like AB was to break it up and add 2 logarithms. So if it's 2 times 10 here, this breaks up into what?
log 10
Log 10 of 2 plus log 10 of 10. And what's log 10 of 2?
0.3
0.3. And what's log 10 of 10?
plus 1.
1. Okay. So you end up with 0.3. That gives you what? 0.05? 0.305? 0.35.
So basically with those, it's just going to be like you separate.
You are
them out
literally
into
undoing
addition.
it. Think it's kind of almost like factoring. You have factoring, you break stuff up.
Yeah.
You're factoring that up into, now if you're looking at that and going, well, why didn't you break it up into 2 times 2 times 5? That's a great question, but I don't have a log of 5. But I do have a log of 2. And even though I didn't give you log of 10, you guys seem to know that pretty quickly, right? Log 10 of 10 was 1. So really, those are the 3 things I know. If I knew what a log of 5 was, I could do it. Right?
Mhm.
Now, for the record, you're going to have to know how to find the log of 5. What if I gave you this and said, what is log base 10 of 5? I can promise you, I know that'll be on your test somewhere. It's not so bad. Now, so far, I've been taking this number and factoring it, right? So that I could break it up with addition, subtraction. Right? That's what I did with the 20 over 9. Well, could I rewrite 5? 10 over 2. So I could rewrite 5 as 10 halves. Now, I see people all the time, they go, hey, if I double it, I'll get 10. If I multiply it by 80, I'll get 400, but that's not real math, right? If I can just go around doubling stuff, where do I go?
The bank.
Go to the bank, right? So I rewrite it so it's the same, and then I use a rule. And what does my rule say here?
Subtraction.
Log 10,
Log
10
to the 10
minus log 10,
log 10
2, and you get 1 minus
So
0.30. And can I tell you that at Hoover, Vestavia, and the state tournament, you are expected to know, and on my test too, I do it for bonus questions, and then in pre-cal, I make you know it. You're expected to know that a base 10 log of 2 is 0.301. You're supposed to know that a log of 3 is what is it, 4.46?
Log 3.
What is it,
0.477.
0.477. And you're supposed to, and actually with those two, think of what you can do.
So
I know log of 5 now because I can calculate it. I know log of 6 because I can break it down into log of 2 times 3. And log of 7 actually, it's probably good to know. It seems like that's like 0.5 something or other. What is it?
0.845.
No, that hadn't been asked. I would have remembered that one. But my point is, these two actually, there are problems if you don't have that memorized, that you can't get them. In fact, once at Vestavia, and Vestavia is always trying to screw you, if you didn't know this accurate to 5 decimal places, which it is accurate to 5 is 0.30103, you didn't get the problem right. Which is just stupid, in my opinion. But because you are required to know these two, because of the problems they give you out to at least 3, I usually make them a bonus question on my test. And I'll say something like, what is log of 8 equal to, with no help? How can I find a log of 8?
0.3 times 0.3 cubed, or 0.301 cubed.
Careful. This, I like what you're thinking though, is this, right? But this is not, this is a really big deal actually when I'm right. Those are not true, are they? This is cubing the whole log. This is cubing just the 2. So these aren't equal. So if you took the 0.301 and cubed 0.301, you just assumed that this was that, and it's not.
Would it be
But it is equal to what?
log 2 plus log 2 plus log 2?
Yes, or even better, swing the 3 to the front.
0.30 or
3 log 2, which is 3 times 0.301, 0.903. Does that make sense? And they'll ask that question. And if you don't have it memorized, which again, I'm not going to argue with you there, it's stupid that part of being a math teamer is memorizing decimal places out on values, but I don't know. I mean, what Miss Tyree asked you to memorize pi? Who got the furthest in here? Or was it Tyree or Coley or who?
I think it's definitely Lily.
Yeah.
Lily, how far did you get?
I don't know. I think maybe like 80. When I did that
80 places?
I don't know.
Oh my lord.
I think it's like 100.
It's pretty far. Yeah, I remember Jack Crouch got really high too. But like I know it, what, 7? Because I remember I was hiking with some friends. We were up in the Smoky Mountains, and Pi Day was on a Saturday, kind of like it was last year. And we were getting up, and I was like, guys, do you know it's March? And literally, it was March 14th. 3.1415. It was 2015, and it was 9:26 in the morning. I was like, it's Pi Day, like out to 7 decimal places. They were like, you are a loser. I'm like, anyway, whatever.
So basically, when it's
But they make you know that.
when it's log base 10.
And these are only base 10s.
So, but that's what you're saying, right? That if you were to plug it into an old calculator and it had log and then the parentheses, it'd be a log base 10.
Correct.
Okay.
Now when you do it, it still does that with these 84s. Like when you hit, like right, look, you hit log, what do you see? Log, right? But they've upgraded these 84s that if you go alpha window 5, it gives you log with the 2 boxes, right? They made an upgrade on it to do that. But you guys aren't going to buy this crappy thing. This is an 84. The only reason you might want to buy an 84 plus CE, they keep adding letters to make it sound more impressive. But the only reason you want one of these is if at the end of this year you're like, I'm not taking math team anymore. I still don't think it's necessarily a better thing for you, but regular pre-cal teachers use these. I use the Inspire because it's a better calculator. It costs a little bit more, but it's just better. So if you buy the Inspire is just, it's more upgraded, it's new technology. This is 34-year-old technology. Like all the basis of all of this was built from the TI-81, which is just an antique from the late 80s. So the Inspire is like within 10 or 12 years, it's pretty new technology. So much better, I think. It's got a little trackpad on it. It's like having your own little mouse, and it's but anyway, either one's fine. In my AP Cal class, because I get half my students from math team and half regular Cal students, since I get them both in here, I have one of each up here, just use both. So it doesn't, you'll be fine either way. All right, let's talk about some things today. And I wanted to talk a little bit more about solving and some things that you'll run into. Now, what I've done here, this is on page, if you want to follow with me, page 46, I think. I've written out little mini equations and placed the x in every possible scenario I could find. Now, obviously, I could make much more ugly equations, but these are the 7 ways when you're solving that your x could end up. Now, obviously, I can end up with an x like this. You already know how to deal with that, don't you, right? Square root both sides. If it's a cube, cube root both sides. And if you end up with this, well, you're actually done, right? X equals 5 squared, just simplify. If you end up with, over here on the far left, this, which is pretty unusual, what would I do to, you're solving for x, but it's done as a base. What do you do, though? It's rare that you see that, but you'd exponentiate, which is not going to help you a ton, but at the very minimum, you can cancel that out and turn it into that, right? But you use, and then also I could have x equals log base 2 of 5, but again, you're done, if that's the case. The problems that you're going to run into by far the most are these 3 situations. What happens when you have an x as an exponent? What happens when you're logging an x that's equal to a number? And what happens when you're logging an x which is equal to a log? And those are the 3 you see the most of. And those you have to be ready to solve. Again, occasionally this, but not very often. So I want to focus on those 3 that I boxed over there. And our goal on all these problems is to make them end up looking like one of these. And if you can get to one of these, you're okay, because what do you do here to solve? Log with a base 2 log on both sides?
Yeah.
And over here, what would you do?
Exponentiate.
Exponentiate with a 2 on both sides. And here, what would you do?
Exponentiate.
You could exponentiate, but since the bases are the same, and there's nothing out in front of the log, you could use that 1-to-1 principle. And just kind of chop, chop, x equals 5. Now, in any of these cases, do you see 2 logs on one side? No. So until you get it to one of these 3 situations, you can't apply these logs or these exponentiate rules or anything like that. You can't do it. All right, so let's check a couple of these out. Walk with me. We're going to try to go as quickly as possible. But walk through me. What would you do right here if you were solving for x and it's up there in the exponent? Just give me one thing you do.
Yeah.
So subtract 2. All right, that gets me to here.
Divide that 5.
Why don't I go 5 times 4 is 20?
Because it has that.
Because I literally can't do that, right? PEMDAS says you would have to raise to exponents before you multiply, and I can't raise it to the exponent because I don't know what the exponent is. It's got a variable in it. But I totally can divide by 5. Now what do?
You want to make the bases the same somehow.
Can't do that. I mean, I would want to, yes, but I don't know how to do that.
So log.
I log it. Because remember, to get rid of a base, which is what I'm trying to get rid of the 4, right? So the x will drop. To get rid of a base of an exponent, I log because they're inverses. Just like to get rid of a log, I exponentiate because they're inverses. But I can't divide it out, can I? So I'm going to log it out. So log 4, log 4. And what happens here on the left? Log 4 cancels. What happens here on the right? Nothing. I could use a change of base rule, but again, I don't need to do that. That's whatever. Now, what do I do now to finish solving?
You put you exponentiate by 4. Oh, wait.
I'm trying to get x by itself. How do you get x by itself?
Subtract 1.
Subtract a 1 and then divide by 3. Great. So subtract a 1 and divide by 3. So log base 4 of 3 minus 1 over 3. Now, I'm fine with you leaving an answer like that when you take this test. But let me show you. Go to Vestavia, State, they're always trying to find a way to hurt you. So, again, my test, great. Because I'm thinking in real life, you're going to type this junk in your calculator. You're going to literally type that in the calculator, subtract the 1 from it, divide by 3, and you're going to have a decimal, and that's going to be great. But they're going to want you to subtract that and that. And can you subtract a number from a log?
Yes.
No. But you can change that number into a log, and then you have a subtraction rule. Hey. Yes. No.
You got contact trace.
Definitely.
I think we got missed.
The old one.
We got
Okay,
red.
so
All 3 of them red, bro.
Is it me?
and
Oh, you're kidding.
Oh, you got
so
saved.
sorry. Yeah. Okay.
Wait, did you already get
Oh, you're gonna say go to the nurses, which is the old counselors, not the new nurses. The old nurses.
That's the second time.
Yes.
That's second time for both of them.
Oh,
Well, the upside of it is, at least it's not full
yeah,
2
no.
weeks.
Well, then they have Thanksgiving.
Yeah, no, it's
too.
like us on Thanksgiving, so it's like
Yeah.
2 weeks.
I can hold this thing.
That's awesome.
You what?
Was it Russell?
No, no.
I mean, like, you're
Uh-oh,
Russell.
I sit by Anthony
It's
beside.
definitely a
Okay, was it Thomas?
Yeah.
Oh, no.
And
I'll see you soon then, I guess.
Bye, Melanie.
Bye.
sorry, guys.
That's
I trust KW, he's never getting sick.
the second.
Wait, where's Russell missing him?
Oh, is it?
I don't know. Hopefully, I haven't heard anything.
Where's he sit?
Right there.
Oh,
I get footsteps.
That stinks, no, I can't.
Stinks,
We
I
got
did have a girl that went back-to-back quarantines. She's been gone a month. She finally got back this Friday. Got back last Friday.
Who is it?
Gracie Robinson.
Oh.
It's brutal. Well,
We got
that's
10
6
left.
days.
So beautiful.
Hmm?
We got 10 left.
I will go
Pretty
do
much.
it.
Yeah, it probably is Thomas. What do you think?
Yeah.
Have y'all heard that about it? You just,
That was what
He
they.
sits by me
Yeah.
at
I was
beside.
told in my first period.
Oh, you're a goner.
Is that
Oh, you're
why?
gone.
I hope it's 6 feet away.
Is he in front of you?
No, he's like about
y'all are 6 feet apart. Y'all are okay here.
That's funny because he sat by me and.
I thought y'all were gonna be going too.
Yeah.
He's like where you.
All right, well, we do what we can, okay? Hey, let me show you a trickier one. Oh, so anyway, look, I've got back to this. How do I change the number 1 back into a log? Do you remember this from Friday? If I have a number like anything, if I want to change it to a log, remember, since if those match, right? If those match, that is happy face, right?
Yeah.
So if I want it to be equal to 1, I just have to make those numbers match. log 2 of 2, log 5 of 5, log 10 of 10, to whatever one. So what base do I want it to match? 4. So I'm going to change that to log 4 of 4 to the first. And then now can I subtract 2 logs? What do I get?
3 over 4.
3 over the 4. So I get log base 4 of 3/4 divided by 3. In fact, on a test, you might even see this. And again, you don't need to do this when you're solving. You might even see this. Oh, and let me just show you. You know, this, I say this, David, they're just not kind. When it comes to making their tests, they just aren't. They're just mean and somewhat evil. If you think about it. Now, that would be kind from them.
What's next?
Are you tracking with me?
What's next? Oh, what's next?
And this is where they probably would leave it.
No. Wait.
See what they did?
Guys,
They rationalized it.
But why?
Because they're evil? I am not. I will take this. Because I realize life is not about this. Life is about typing it in the calculator, getting a good decimal approximation. It's accurate enough that it won't hurt you. Are y'all with me on that? So, could I give a bonus? Pause, I can do anything on a bonus because it doesn't hurt you. All right, what about something like 10 and 11? Oh, by the way, no, 8. You need to go to 8. What about 8?
You can just replace that 5 to the x of the 8.
What? Are you about to say substitution?
Yeah.
Why would you do that? Because you don't smell a power squeeze, you smell, this needs to be what?
Unified.
Factored.
Oh.
Guys, when you look up here and you see something like that in a couple of spots, think substitution. Think, hey, I don't like the way that looks, but if I replace that with some variable like a, b, whatever, I end up with b squared. Actually, I do not know 3 squared when it's a.
Ours is already a variable.
Oh, yours is an e?
That's all.
Oh, I know why I changed it, because we hadn't talked about natural logs yet. I changed this. So pretend that it's, I'll tell you what.
We already
We'll
did
do
this in another
yours.
unit.
Yours is e to the 2x and e to the x?
Yeah.
Okay, so if it's bothering you, replace e to the x with a, and you get a squared minus 3a plus 2. Could you factor that now? And it doesn't look ugly anymore, does it? So you would factor it into an a minus 2, a minus 1, where you get a equals 2, a equals 1. And then you replace it. And then now you are here with a log problem, or an exponential problem that you need to do what? Now, the reason I took those e's out, because we haven't talked a lot about e, but what do you do to get rid of a base of e, just like you did to get
Log E.
log base e? How do you write? I'm going to write it once. But what is log base e doing that to both sides like this? Does cancel, and it leaves you x equals log base e of 2. But we don't write log base e. Instead of log base e, what do we do?
Right now.
301.
No,
Wait, that's
hold on. We don't write log base 2, we write ln, which means log base 2. And when I'm looking at ln of e, because I know that ln of e means log base e, those cancel. But here, I just end up with ln2, which again means log base e. Now, when I normally say that, people go, well, can I just write log base e? The short answer is no. Can you think log base e? Can you write log base e and then change it? You can, but I'm telling you, it's like walking. It was really hard at first. Okay? I had 3 kids, watched them bang their head on coffee tables. Like, some of them went around with bruises on their forehead for like weeks, family pictures. What did you do to your children? I mean, just from falling and whacking and whatever. But I don't see anybody falling. You guys walk around the school, it's impressive. Very rarely do you trip and fall. When you do, you know, it happens. What about e to the x equals 1? ln the e to the x, ln the 1. What is ln of e to the x give me? X, because it's log base e of e to the x. X. What's any log of 1 as long as the base is okay? And the base is okay because y'all know what e means? It's about 2.7. It's really an irrational number like pi is. It goes 2.7182881, blah, 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 and then changes for the rest of the whole eternity. With no pattern, no reason, no rhyme. And what does it mean? E means the limiting value as x approaches infinity of 1 plus 1 over x to the x. But this shows up in compounding growth equations. It basically means there's a ratio at which compounding interest grows, compounding any kind of growth rate. So this translates to the part of an exponential equation when you have continuous compounding. So like bacteria growth is constantly growing, right? As opposed to like people, where we're birthing a person here and then birthing a person there and birthing. Bacteria is doing that, but at such a rapid rate it seems almost continuous. This shows up in those. Do you ever remember seeing this equation? Pert equation? There's your E. But in a regular exponent, maybe you haven't, but in a regular growth equation you would have seen this. Anyway, whatever, you don't have to know any of that. But anyway, that's what the ln and the E. The E is different from ln, right? E is about 2.7. ln means the log with a base of about 2.7. So don't confuse ln for E, they're different. One's using the E, one is the E. And then right here, are we good? What would you do? Divide by 4 and get 1.25, and then what? So you're going to divide by the 4 and get this, 5/4. And then you're going to log base 3 on both sides. And that's going to get you to here. Now again, I don't need you to separate this into log 5 minus log 4. Don't do that. We're simplifying, we're good. And then the last step, divide by 2. And you don't need to think about this as a 1/2, and then swing it up there to a 1/2 power, and then end up with log base 3 of root 5 halves. That's what it would end up being. These are equal. We don't need to do that. We can just leave it like this. Y'all seeing that? And these are exponential equations. What are all of these? Talk to me.
Logarithmic.
They're logarithmic equations. So on all the exponential equations, you had to do what at what point?
Exponentiate.
On all the exponential equations, you had to do
Oh, you
what?
had to log.
You had to log. And all the log equations, you're going to have to
Exponentiate.
exponentiate. But you can't do it until you get down to one of these 3 boxed things. You'll notice on all the exponentials, I had to get it down to this. I wasn't going around logging at any point right off the bat, was I? I had to get it down to where it was just a single base to a power. And when you're doing the log problems, you have to give it down to a log of a base of a number. If there's other junk going on, you've got to clean it up. Is this log of a base of a number yet? No, because the 2 and the 5 are in the way. So deal with it. What do you do first? Subtract the 5. Great, that gets you to here. Now what? Divide by 2. Great. Now what? Exponentiate. But I can't exponentiate here. Every year I have somebody who tries to go exponentiate, exponentiate. I can't do that when the 2 is there. Actually, I can, but it turns into a 9. We don't want that in the problem, and most people forget it. So get rid of it and get it down to just a log, then we can exponentiate with a base of 3. And I get x equals 3 to the negative 1/2. What's a better way to write negative 1/2?
Negative 1 minus. Wait.
What does the negative part of the 1/2 do?
Puts it on the bottom.
So it puts the 3 to the half on the bottom?
And then
And what does the 1/2 mean?
square root.
Square root of 3? And what do we always do in algebra 2? Rationalize. So root 3 over 3. Are y'all seeing that? What about, I think number 11 is a lot like number 10. Are we gonna, on this one right here, are we gonna do this? Are we gonna divide by 3 first? Yes or no?
Yes.
Yes. Are we gonna add 2 second?
No.
No. I can't get inside of that parentheses unless I free it from the logarithm. So how do I free it from the log?
Exponentiate.
Exponentiate. Now it's free. 2 to the 4 is 16.
X minus 2, X equals 18.
And all the while I need to be checking my answers to make sure I never log a negative number or a 0 or any weird thing that breaks my domain. But all of these so far have been great. What about this one? Should I exponentiate? Absolutely not. Why not? Because if you think back to our rules, we can only exponentiate when we have a single log on one side. Now, if I have a single log on both sides, I can exponentiate also. But I cannot exponentiate when I have 2 logs on one side. This would be the equivalent of it. Is this a true statement?
Yes.
If I exponentiate,
Of course.
now, that is true.
Oh, no.
Right? But here's what people end up doing. They exponentiate like this.
Dude.
And you're literally saying 64 plus 16 equals 1024. That is not true. You cannot exponentiate like this, okay? But it's so tempting when you're a young log manipulator like yourself. So help me out right here with these 2 logs. How do I add these 2 logs so that I don't have 2 logs on one side?
Well,
Foil it.
I multiply those 2 things. So I combine it to 1 log by multiplying these 2, 3 together. Now, I'm hearing FOIL. That's absolutely right. You don't have to do this and multiply them in this first step. But now at what point can I exponentiate now?
yeah.
Because I have 1 log. And yes, I'm going to end up foiling this.
Wait, yeah, can you just?
Do the 1-to-1.
Yeah, or use the 1-to-1 principle.
Let's go.
But hey guys, isn't exponentiating both sides right now the 1-to-1 principle?
Yeah.
Yeah.
But absolutely you can do it. You don't have to write that. You get 2x squared minus plus 3x minus 9.
Yeah.
Something like
X squared. X squared is canceled.
Cancel the 2x squareds.
9.
that.
X equals 3. Now, double check. Plugging a 3 in here. Will I be logging a negative anywhere?
Oh.
No, so I'm okay. What about 13?
First.
Can I exponentiate?
No, because you don't
No.
put the.
So I can't do that because I don't just have a log and a log or a single log. I got a log and a number.
Make the 1 a log 2.
She's saying change the 1 to a log 2 of 2. Okay, this is option 1. Log 2 of 2. Now, how could I simplify this now? How do I add 2 logs?
Log 2 to the 6x, you multiply.
Log base 2, multiply. And at this point,
1 to 1.
1 to 1, which means I could exponentiate or just cancel them.
X plus
Either way,
1.
it's the same thing, right? And I get x plus 1 is 6x.
5x.
So x is 1/5 after you subtract the x and divide by 5.
No negatives.
And when I plug a 1/5 in there, does it give me a negative number? Or 0? No. What about 14? Oh, by the way, this is one way to do it. I'm going to leave my answer right there. Is this another method? Subtract that log from the other side. How do I subtract 2 logs? By doing what? By dividing? At this point, how would I solve that and get rid of that log? Exponentiate, and I get x plus 1 over 3x equals 2. Isn't that x plus 1 equals 6x? Subtract an x, divide by 5. Or, could I change that one? Well, no, we did that last time. So anyway, lots of different ways to go about this. What about this? What would you do?
Put the exponentiate by, or wait, change the 2 to a log. To a log.
You could. Wouldn't it be easier just to exponentiate? With a what?
10.
With the 10? Because understood, when you don't see a base, that means it's base 10. Unless it's ln. Then it would be basic. And then what happens here if this is 10 log 10?
Cancels.
And you get x minus 3 is 100?
100. X is 100.
Okay, I'm going to jump to, well, no, we got time. Actually, I'm going to jump to 16. Right here. Help me out. How do you add two logs? Or how do you solve that?
Multiply them together.
Multiply them. So you keep the log and you multiply that times that. So that would give me x squared plus 2x. Now what?
Make the
You
3
could change the 3 to log what?
log to the 8. Log 2
Log
of
base
8.
2 of 2 cubed, which would be log base 2 of 8, and then cancel log base 2. But I'd just say, what could you also do?
Exponentiate by 2.
Exponentiate.
8.
And then there's your 2 cubed. You didn't have to think so much. Now, I want you to be really careful. This is the first time you'll see it. To solve that, what would you do?
Factor.
Set that equal to 0. When you factor, you get x plus 4x minus 2, which gives you negative 4 and 2 as solutions.
But we
But
know.
look, if
No.
I plug a negative in there, I'm logging a negative.
And
And I happen to be logging a negative here as well when I plug in a negative 4. So I can't use negative 4. And let me hammer this in. It's okay to have an answer that's a negative. What's not okay, and it's okay to have answers that are positive. What's not okay is to plug those numbers in and end up logging a negative number. Are y'all seeing that? So like, what if this was, if I had like log of 6 minus x plus log of negative x equals blah, 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 and I ended up with negative 4, if I ended up with negative 4 and 2 for my answers, which ones work? The negative 4 actually would give me 10 here and 4 there. That would actually work. But the 2 would give me 4, but negative 2. I'd have to throw it out. So again, it's not that the number's negative that makes it bad. It's that when you plug it in, you might be logging a negative, and that's bad. Are y'all hearing that? And then the very last couple we've actually addressed today. But this says, how do you expand logarithms? We've already talked a little bit about it, but I want to talk a little bit more. Expanding a logarithm, I want you to take this and break it up into as many logarithms and as much as you can. Can I do that? And the reason I can is because this is 8 times y over z. So what would have been added or subtracted that would have ended up being that?
You add the x and y and subtract them.
So I would have added log base 2 of x with log base 2 of y. And sure enough, that would have given me log base 2 of xy. And then I would have what? Subtracted log base 2 of z. Every year I have somebody write this. Log 2x times log 2y over log 2z. That is not what this is saying, right? I don't even know how to multiply logs and divide logs. We haven't learned that. What we've learned is how to add and subtract logs. What about this one? Help me out.
log base 3 x squared minus log base 3 y to the 1 half.
Can I simplify it any further? Could I swing the 2 out to the front? Now let me show you why I would want to do that. And that's y to the half, so swing a 1/2 out front. This is why I would do this. In this problem, I might say log of x, log base 3 of x is a. Log base 3 of y is b. And the question might be, write your answer in terms of a and b. So now I can go, well, if that's a and that's b, then I have just written that in terms of a and b. And you know what the biggest mistake I see is? This right here. They change this, and they go, oh, if log base 3 of x is a, then this is a squared. If log base 3 of y is b, then this is b to the half. What did I do? What did I assume there? Maybe.
That was funny.
I'm assuming that I am squaring all of it. But I'm not squaring all of that a, am I? I'm only squaring the a. So don't think that way. You move that 2 to the front. Move that half to the front so that you can really see what your log 3 and your log 3 of x and log 3 of y are. All right, we're out of time. Hey guys, do the best you can on all of this. And tomorrow, we'll just pick up where we left off. Good job again with it.
I think the Christmas tree is that.
Man, I hate the quarantine.
I thought it was gonna be
Smell it from mine.